Hey guys, this is Mrs. Henderson, and today we are going to talk about multi-digit multiplication and how to solve these problems. When we're dealing with multiplication, the first thing that I want you to remember is the vocab, of course. So we have the word factor. If I have the equation 3 times 3 equals 9. My factors are 3 and 3. So the numbers that we multiply together are factors. All right, if we have 3 times 3 equals 9. The answer to the multiplication problem is the product. And you will see this word a lot, and you have to know what it means. So a question could be, what is the product of 3 and 3? And you would have to know to multiply those together to get the answer. Multiplication, one way to think about it is I have blank groups of blank. So in this case, we have 3 groups of 3. And what that looks like is we have 1, 2, 3 groups of 3. We have equal groups. You can also think of it as I have this number this many times. So in this case, we have the number 3 times. So we have a 3, and we have a 3, and we have a 3, which gives us the product of 9. All right, we learned to solve multiplication problems, guys, using the standard algorithm and then the box or the area model. So I'm going to go over the standard algorithm first, and then we will talk about the other model. When you are solving problems like this, if they give it to you written out horizontally like this, you have to stack it. And we talked about lining up our place values. So the first thing we do in 22 times 4, we're going to multiply 4 times 2. And that gives us 8. All right, then step number 2, you're going to multiply 4 by the 2 that's in the tens place. And 4 times 2 is 8. So the product is 88. The product of 22 and 4 is 88. All right, when you have 3 digits on top, times 1, and I taught you guys to solve this type of problem so that you would be able to check yourself when you're dividing. Sometimes you'll have a 3-digit quotient, and you have to multiply it by the 1-digit divisor to check yourself. But you start out multiplying your digits that are in the ones place. 4 times 3 is 12. All right, so we're going to put the 2 down, and we have to regroup the 1 over the tens place because we haven't multiplied by the 2 that's in the tens place yet. And we are going to draw our circle around all 3 of those. It's more like a stretched out circle. But we want to put all 3 of those digits inside of that because you guys like to forget to add in what you have regrouped. So that kind of helps us to know not to leave it out. 4 times 2 is 8, and we're going to add 1, and that gives us 9. And now we're moving on to this digit that's in the hundreds place. We have to multiply it by the 4. 4 times 3 is 12. Now, I'm not going to regroup that 1 because I ran out of digits. So you can write your 12 down as part of your product. All right, so the product of 323 times 4 is 1,292. And finally, we had to learn how to multiply 2 digits times 2 digits. This one got a little bit trickier for us. And so some of you guys, it was really hard to see it this way. And so I showed you how you could break it apart and then put it back together. So what that means is you could say 63 times 9 and solve that. And then 63 not times 1. It's the value of this one. It's in the tens place, so the value is 10. 63 times 10, and then you would add those two products together. To solve it this way without breaking it apart, you start with your digits that are in the ones place. 9 times 3 is 27, so we're going to regroup the 2. 9 times 6 is 54, and we're going to add 2 more to get 56. So the product of 63 and 9 is 567. All right, we're not multiplying by 1 right here, guys. We're multiplying by 10. So you need a placeholder 0. We're going to get rid of this 2 that we regrouped. We're finished with this 9. We've multiplied it by the 3. We've multiplied it by the 6. We can't do anything else with it. So because we put this placeholder 0 down to take care of the fact that this is 10 and not 1, you can do 63 times 1 now, which would be 63. So over here, 63 times 1 is 63, and then we have to add on that 0. So the product of 63 times 10 is 630. And now we're ready to add our two products together. So we get 7, 9, and 11. So the product of 63 and 19 would be 1,197. All right, we're going to solve the same 3 problems using the area model. And I like to call it the area model instead of the box method because we have a formula for area. Length times width. Length times width equals area. So how long the rectangle is times how wide it is. So for 22 times 4, it's a 2-digit by 1 digit. So you need a 2 by 1 box. You need 2 across, 1 down. Put 22 in expanded form, which would be 20 plus 2. And then your 4 represents the width. So to get the area of each rectangle, it's length times width. So the length for this first one is 20, and the width is 4. Find your hidden fact, which would be 4 times 2, that's 8. But we're not multiplying 4 by 2, it's 4 by 20. So we have to add on this 0, which gives us a product of 80. All right, to find the area of this rectangle, the length is 2 and the width is 4. 2 times 4, which is 8. So the product is 88, which is a match. It's two different ways to solve the same problem. All right, on the second one, we have a 3 by 1 multiplication equation. And so we needed a 3 by 1 box. So 3 across, 1 down. And then we're going to put 323 in expanded form. So it's 300 plus 20 plus 3. And then your 4 would represent the width. So the first rectangle, the length would be 300 and the width would be 4. Find your hidden fact. That's 4 times 3, which is 12. But we're not multiplying 4 by 3. It's 4 by 300. So you have to slash those zeros and count how many you need to add on, which gives you 1,200. The second rectangle has a length of 20 and a width of 4. 4 times 2 is 8, and we need our placeholder 0. And then the last rectangle has a length of 3 and a width of 4. 4 times 3 is 12. When you add your 3 products together, you get 1,292. And finally, we have a 2 by 2 multiplication problem. So we need a 2 by 2 box. 2 across, 2 down. 63 we need to put in expanded form. So that's 60 plus 3. And then 19 would be 10 plus 9. Length times width. So this top left rectangle has a length of 60 and a width of 10. Find your hidden fact, which is 6 times 1. That is 6. And then add on, we need 1, 2 zeros. It's 600 because we're multiplying 10 by 60. All right, this last rectangle on the top has a length of 3 and a width of 10. 10 times 3 is 30. All right, bottom left, the length is 60 and the width is 9. So your hidden fact would be 9 times 6, which is 54. But it's not 6, it's 60. So we need to add that 0 on to the end to get 540. And finally, our last rectangle has a length of 3 and a width of 9. 9 times 3 is 27. So in this case, you have 4 products that you have to add together. And when you do that, you get 1,197. So again, this is just a second way to solve the same problem, or a way to check yourself to make sure you have the correct answer. Remember, when you are estimating products, you want to round to the front digit because we want to have that the zeros at the end, just like we used here. So you're going to round to the front digit. And so 22 would round to 20. And then if you guys remember, we wrote this in our notebook: never, ever, 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 ever round a 1-digit number. We're going to leave that for a 4. Find your hidden fact, which is 4 times 2. That gives you 8. Slash your zeros, count them. That's usually the biggest mistake here. You guys won't add enough zeros onto the end. In this case, we have 1 0 that we need to add on because we were multiplying 4 by 20, not by 2. So 22 times 4 is about 80. And if you will go back and look at the actual product, 80 and 88 are pretty close to each other, and estimates should be close. They are a thoughtful guess close. All right, 323 times 4, we're going to round to the front digit. 323 would round to 300 times 4. Find your hidden fact. 4 times 3 is 12. And then let's count those zeros. It's not 4 times 3, it's 4 times 300. So we have to put those zeros on. So 323 times 4 is about 1,200. Are we close? Yes, we are pretty close. All right, now we have a 2-digit by 2, so we're going to round both of these to the front digit. Both of the factors are going to be rounded to the front digit. 63 would round to 60. 19 would round to 20. Find your hidden fact. Oh, I see it. 6 times 2, which is 12. Let's slash those zeros. How many do we need? 2. So 63 times 19 is about 1,200. About. And the actual product was 1,197, 98, 99. So we are 3 away. It's pretty close. This estimate is bigger than the actual product, so that's an overestimate. This estimate is smaller, so that would be an underestimate. And then this one is under the actual product. So it's a little low. Still pretty close. All right, we are going to practice 2 word problems. I want you to remember what multiplication word problems can look like. The first one says Mrs. H had 63 baskets. Each basket had 19 eggs. How many total eggs does Mrs. H have? All right, so the first thing we do, we just read the problem. We don't write on it. We don't do anything. We just read it. Then we're going to go back and we're going to put a box around numbers and labels. So Mrs. H had 63 baskets. So I'm going to put a box around 63 and 63 what? Baskets. That would be my label. Each basket had 19 eggs. Okay, so 19 what? Eggs. How many total eggs does Mrs. H have? You guys know I like for you to underline the question because I want you to go back and make sure that your answer makes sense and that you are answering the question with whatever your answer is. All right, then we look for the action or anything in the problem that can help us, and we put a circle around it. So we're looking for the total. When you find the total, that's the how many in all, that's the put it together. And then each basket had 19 eggs. So it sounds to me like I have 63 groups of 19 eggs, 63 baskets of 19 eggs. And that's a multiplication problem that we've already solved. I tried to stick to the same ones. 63 times 19, 1,197. Eggs. Okay, so let's see if this makes sense to make sure we perform the correct operation, doctors. How many total eggs does Mrs. Henderson have? So if I have 1,197 eggs, does that make sense? I have 63 baskets. That's a lot of baskets. And this basket has 19 eggs, and basket number 2 has 19 eggs, and number 3 and number 4. Does it make sense that we have an answer that is this big. Yes. I think we performed the correct operation. All right, then you might have a comparison problem. Mrs. H gave 22 math problems on Monday night for homework. On Tuesday, she gave 4 times as many problems for homework than Monday. How many problems did Mrs. H assign for Tuesday night's homework? So I just read the problem. Now I'm going to go back and put some marks on here to help me kind of map out my thinking. So Mrs. H gave 22 math problems. So I'm going to put a box around that. That's my number and the label that goes with it. And that was for Monday night's homework. Might even put a box around that. On Tuesday, I want to keep my days separate. She gave 4 times as many problems. Wow. For homework than Monday. And then we're going to underline the question. How many problems did Mrs. H assign for Tuesday night's homework? That's important. 4 times as many. So if I assigned 22 problems on Monday, then on Tuesday I did 4 times. That's times 4. That's for Tuesday. And that's a problem that we solved a few minutes ago. That's 88. All right, so let's see if this makes sense. How many problems did Mrs. H assign for Tuesday night's homework? Does it make sense that if I'm assigning 4 times as many, that's 22, 44, keep going, keep adding on 22s, 4 times, does it make sense that it would be 88? I assigned 88 problems on Tuesday. Wow. Well, first of all, I think that's too many. Your parents would probably think that's way too many too. I would never do that. So that's what a multiplication comparison, there you go. That's what a multiplication comparison problem looks like. It'll say something like 4 times as many or 5 times as many. So just watch for those. If it says 4 times, that means times 4. All right, guys. Multiplication and how to solve multi-digit multiplication problems. There's your video. And take care, and I'll see you in the next one. Bye-bye.